Welcome to ICM-Online problem series in mathematics on real analysis. Problem number 9. Suppose that sequence xn is a sequence of real numbers satisfying the following. For every epsilon greater than 0, there exists n naught, such that absolute value of xn plus 1 minus xn is less than epsilon for every n greater than or equal to n naught. The sequence xn is option A, bounded but not necessarily Cauchy. Option B, Cauchy but not necessarily bounded, or convergent, or not necessarily bounded. Let us discuss the answer. The given condition that for every epsilon greater than 0 there exists an integer n naught such that absolute value of xn plus 1 minus xn less than epsilon for every n greater than or equal to n naught means that the sequence xn plus 1 minus xn converges to 0. Consider sequence of root n, square root of n. Then square root of n plus 1, which is xn plus 1, minus square root of n. After computation, it equals 1 by square root of n plus 1 plus square root of n, which approaches 0 as n tends to infinity. But square root of n is unbounded. So that is, we obtained an unbounded sequence which satisfies the given condition. Such sequences which satisfy this condition are also called Pseudo Cauchy sequences. So we obtained an unbounded Pseudo Cauchy sequence, which is sequence square root of n. Thus, option A is false. Now, option B is clearly false because every Cauchy sequence in R converges, hence bounded. Now, option C is also false. It is clear from the example which we have provided. Since sequence root n is unbounded, it cannot converge. Now, option D is true because as we see from the example itself, a Pseudo Cauchy sequence need not be bounded.